Hi, I'm Pawel and I make games. I'm gonna show you how to change scenes in Unity smoothly. To help ourselves a lot, we're gonna use Singleton pattern there. For now we have two Unity scenes and inside them we have canvas with UI, main camera, two decorations, a dummy manager which will be written in this tutorial, and some game objects for later usage. First we need to make it possible to change scenes anyhow, so let's go to our canvas and there we have a simple default Unity's button. As default you will have something like that, so you just need to click this plus icon to see some more options. That's the first role of our dummy manager. We need to click this game object, edit script, and first add those two libraries. As you can guess, the first one is related to UI, and the second one allows us to change scenes. All we need to do for now is to create new public void change scene, and because we want to be able to choose which of the scenes we want to load, we need to add a new argument of type integer there called scene index. Inside we need to access scene manager dot load scene and simply put scene index over there. We've mentioned scene index, so let's see what it is in Unity. Go to File, Build Settings, and there you have your scenes. As a default you will see something like that, and to add your scene to scenes in build, which means being able to load them during the gameplay, drag and drop them into this box. On the right you see numbers, and those are indexes of these scenes. They start from 0 and it's important to remember. Now we may close it up, go to bottom and use dummy manager over there. Now select function, and there is our change scene function. Let's use it and change the number to 1. Now let's go to scene 2, save changes in the scene 1, and let's do the same. Let's find the button, let's use dummy manager over there, and change scene to scene with index 0. Now we may go back to scene 1, save changes in the scene 2, and see how it looks like now. We can change scenes, but it looks really basic. And now in the dummy manager we need to create a new private IA numerator, change scene coroutine. There we're gonna create the simplest possible scene transition. Cover up the scene, change scene, show the new scene. And we also need a scene index there. Now to change the scene we simply need this line, and to get rid of this red line we need to use yield return null. It simply waits one frame and it's necessary for IA numerator. Now let's start this coroutine with start coroutine and its name, and give it the scene index. We need to keep this function because our button doesn't see our IA numerator. Alright, to cover up the scene, we need a blocking canvas, and you know what? Let's create it from scratch. Let's go to UI, canvas. Now we have a new canvas, and let's change its sort order to 1 to keep it in front of this number. Now let's create an image type child for this canvas. Let's click on this icon and holding the Alt key, let's click the bottom right button. Now let's change its color to black and change its alpha to 0. Okay, for now let's leave it as it is and go back to Visual Studio, and first let's grab it. Create a new public image, blocking image. Now let's use it over there to cover up the scene. We need to grab a color. This will be a new color, but we can't use new because it's a keyword. So let's use target and set it to color.black. As you can see, its value is 0001. The fourth number is the alpha, and its value can be between 0 and 1, and if it's 1, it's fully opaque. Now to change the color of the image, let's use while loop and do something as long as this color is not the target. Inside we want to set blocking image color to color.lerp. Now to check out how it works, let's use it in a simplest way that may come to your mind. So let's begin with using blockingimage.color as a starting color, and then use target as our target. And to interpolate this, let's use time.deltaTime. That's the time between 2 frames, and we don't want to do all of that in 1 frame, so let's use yield return null, which allows us to animate this transition. We simply change the color of our blocking image, change the scene, and after that we want to go back, so let's copy and paste this while loop and change the target to color.clear. That's basically black but with 0 alpha. Now in Unity we need to go to this dummy manager and grab this image. Maybe let's also rename them so we know what we are looking at. Let's enter the play mode, hit this button, and nothing happens. That's because in the blocking image we have this raycast target turned on. That allows us to click on this UI element, and because this is in front of that canvas, we can't click on this button. Alright, let's give it another try. Now we don't have this raycast target. We changed the scene instantly because I made a mistake, and instead of being different, I said color must be the same as target to animate it. Now we see the changes, but this color turns black very fast at the beginning, and near the end it slows down. That's because this function is used incorrectly. Let's say it one more time. First we need some new variables. We need a float type called elapsed time. Let's set it to 0. We also need another float called duration. Let's set it to 1. And to make it clear what exactly this duration is. Let's name it duration in seconds. The last float we need is percentage complete. Let's set it to 0. We don't need to do that because 0 is a default value of float, but it makes it clear what we start with. Now we need to save the old color, the color we start with, so it is blocking_image.color. Alright, now let's replace the first color with old, and this time delta time with percentage complete. So we have old color, target color, and the percentage which defines to which of them the current color is closer. So, for example, if you have 0.5 as a percentage, the old color is black, the target color is white, we get gray. If the percentage is 0.75, we get light gray. So this function simply interpolates between two colors, and to know to which of them it's closer, it uses a value between 0 and 1. Alright, but we need to update this variable, so after this line let's use percentage complete and set it to elapsed time divided by duration in seconds. But now the elapsed time stays at 0 for the whole time, so let's update it too. Let's use elapsed time and increase it by time.delta time, which is the same as a gap between two animation frames in this example. So it is reasonable to use time.delta time there. Alright, let's see how it looks like now. Enter the play mode and click this button. Okay, in about 1 second we change the scene. That's our duration of the animation. After that we start loading the scene, but because it's this really tiny one, it is done in basically no time. Okay, but after that we change the scene and our coroutine can't continue the code because it's in the different scene. Okay, and that's the time when we need to use Singleton pattern. We have a simple game object over there with a Singleton script. Let's open it up. And here we need to add a public static, which means this variable is shared between every instance of this class, of the Singleton class. And let's add its type, it's Singleton, and the name is instance. Okay. Now in the awake function, which happens as soon as it is possible, if the instance is null, and if yes, we want the instance to be this, and we want to mark it to not be destroyed after changing the scene. So let's use don't destroy on load and put game object there. If we have an instance saved, we need to use else and destroy our game object. But it happens really late in Unity. So to make sure that this game object doesn't do any actions before it gets destroyed, let's use GameObject.setActive and false. Now before anything happens, we set this game object inactive. We can't do any actions automatically. And then we destroy it. Alright, and now let's go to Unity and move this blocking canvas to Singleton. Let's see what happens. As you can see, we have a new group over there, don't destroy on load, and there's our Singleton with the blocking image. Now as we go to the next scene, we keep those game objects there, and there's our new scene. Just to make sure, let's go to the scene 2, and as you can see, we don't have the Singleton there. Let's go back to the scene 1, because it's not over. As we go to the scene 2, we have this black screen because our blocking image is black, and the dummy manager which changed the color of it is in the scene 1, but we also have a dummy manager in the scene 2, so let's use it. Create a new private enumerator. Change color, or maybe change image color. Okay, and there we want to use this part of the code. And now we miss some variables. So let's use image, emg, color old, color target, and start this coroutine inside this coroutine and inside our start function, which happens as the game manager is set active or as we enter a new scene. Okay, let's copy this name, use start coroutine, paste the name, and inside the brackets we want to use blocking image, old, and target. Oh, and we didn't use this emg as blocking image. Okay, let's add a semicolon there and add yield return start coroutine. Now we wait until this coroutine is finished before going on. Now we don't need this part of this coroutine with the safety line because we have yield return there. Let's get this line, put it over there, but for now let's take care of those two lines. We can just use color.black instead of the target, and we may use this instead of old. Now this coroutine looks quite organized. Let's go to the start function and then let's call a change image color coroutine. Okay, but what we need? We need clear instead of black. Okay, but how do we get this blocking image in the second scene? In Unity we have this blocking canvas as a child object of Singleton, and this blocking canvas has a blocking image as its child. So let's set blocking image to Singleton dot instance dot get component in children image. And as we are here, there are two important things to mention. First, we use it in a start function, and Singleton works in awake. If we want to use awake here and use this line over there, we may do it before the Singleton sets its instance. So for the first scene we will grab null and then we will get an error. We can manually set script's execution order, but to make it easier we may just use it in the start function, which happens after awake. now we can always grab the blocking image, so we don't need to make it public. Let's set it to private. And if you want to be super sure about the safety of your singleton, you may check if you can do something like that. Singleton dot instance equals null. If you can do that from the different class, it means your singleton isn't that safe. To fix it in basically no time, you need to go to your public static singleton instance and add their curly brackets, right, get, which means we can get this variable, and also write private set, which means only this class can set the value of this instance variable. Now we have an error over there, but we still can access what is inside this instance, as you can see. We just can't change what instance is, but we can access it. Alright, we get this blocking image. At the start we change this blocking image to be fully transparent, and as we want to change the scene, we make it black. And then we go to the next scene and we do the same. Okay, let's test that out. We go to the first scene, we go to the second scene, and as you could see, we had an animation over there. Now let's go back, and it works perfectly. Oh, and I've almost forgotten that our blocking image doesn't block things. That's because there, just as we change our scene, we need to block UI. We achieve that by accessing blocking image dot rake as target set to true. Now we can't click on things because our blocking image is in front of everything and it is clickable. Rake as target is set to true, and that means we need to set it to false after we show the scene. Or to make this tutorial way less chaotic and shorter, cut those lines and use them at the end of change image color enumerator. Now we want to set the blocking image on and off based on our target.alpha. So if it's closer to 1 than to 0, we block UI. And that's it. Feel free to ask me some questions in the comments below. Have a good day and see you soon!